Good afternoon everybody. My name's Chris Guest, I'm the Managing Director of LSPB. Welcome to our latest video update. We're here today to talk about disease resistance. In the last 5 years in the UK, most of our major oilseed rape varieties have featured the R gene RlmS. I'm delighted to be joined today by my colleague from MPZ Innovation, part of MPZ, which is LSPB's shareholder, Dr. Stefan Rees. Stefan has been with MPZ since 2014 and he is an expert in plant phytopathology. Stefan, thanks very much for your time. Maybe could you give us an introduction to MPZ Innovation and the work that you do within the breeding process?
So, welcome first here to the greenhouse of MPZ Innovation. So MPZ Innovation is a service and research company offering activities in various areas of breeding, plant breeding, and here with a special focus on rapeseed breeding. So we offer our work for MPZ KG, so the breeding company mainly, and its affiliates like LSPB. We are screening genetic diversity, working on breeding processes itself and developing molecular tools for the breeding process. A significant part of our work makes up plant diseases and resistances. In other words, designing or finding new traits that can protect the plants against pests and pathogens. That's why we're also here today in Groß-Lüsewitz in our greenhouse, which is our experimental unit where we run different biotests against all the major pathogens of rapeseed. And today we are focusing on stem canker, since we are going to talk about RlmS as a new trait available now in the rapeseed market.
You mentioned RlmS there. RlmS has been the mainstay for the UK market, but we've seen a gradual shift in the pathogen population or race, and maybe you'd be a little bit more descriptive on that for us. So it's really great that we now have a new resistance in RlmS coming to the market.
That's true. I think it's in general very important to change resistances over time. It's a natural evolution in the field that plants and pathogens co-evolve together and develop resistances or virulence respectively. And that's also, of course, the case for the pathogenic agent of stem canker called Leptosphaeria maculans, which is a soil-borne fungus that infects the winter-type rapeseed in autumn and then progresses over the winter in the stem and causes a much more significantly damaging stem canker before flowering or at flowering. So there are various resistances available in rapeseed, and RlmS has been a major resistance for a long time, very efficiently, but the pathogen exists not as a uniform race in the field, but with different races. And depending on the race, it can either infect RlmS or not. And over time, the pathotypes that can actually not infect RlmS decreased, and at the same time other pathotypes or races increased or build up in the field that are still able to infect RlmS. And that's what we see nowadays more frequently at different regions, that plants that contain RlmS resistance are becoming susceptible and show typical symptoms of stem canker.
Maybe just for our viewers, would it be possible to actually show that difference? How does the different R gene resistance sort of work on the cotyledon, and maybe then what that means into the growing plant?
So as I said, here in Groß-Lüsewitz in our greenhouse facility, we're employing different biotests to screen material for resistances, but also to characterize isolates from the field, because we want to know what is the virulence of the pathogen in the field, to be able to select the right resistance that can give good protection for the farmer at many fields as possible. So we did infections, as we can see here to the right hand side, either on the cotyledon stage with two different pathotypes and also on the adult plant stage. So at the cotyledon stage, it's a very simple one. So right after germination, we put spores of particular pathotypes on the leaves and then give the pathogen the chance to enter the leaf and spread and cause the typical symptoms. This is a pathotype that has been in the field for many years and where RlmS was pretty efficient for. As you can see here on this variety here, that contains RlmS resistance, and although we do see little black spots here, these are the sites actually where the infection took place. The pathogen is not able to progress in the leaf and to cause damage later on in the plant. While we do have now pathotypes regionally coming up or selected by recurrent growing of RlmS resistance, they are now able to infect the plants. This is a different one, a different pathotype, and this is again the variety with RlmS, and now we do see clear symptoms here, so the pathotype can change in the environment and it needs new resistances to combat this disease. Particular thing of RlmS is quite fairly silent at the cotyledon or leaf stage. You can have RlmS infection with either pathotype, but what is more interesting with RlmS, it becomes a very strong resistance in the adult plant, as we can see here. So this is a variety that contains RlmS, and here we did stem canker infection at the stem about 6 weeks ago now, and the plants look perfectly fine. You can see here the remainings of the infection process, and there are no necrotic spots, and the plants look very well. If we do the same infection with plants without RlmS, then we get strong necrotic spots at the stem base, the typical canker, as you can see here in the stem, so macerated necrotic tissue. The plants will start to wilt and every once in a while even die off. We know that the field resistance, of course, or the adult stem resistance is much more important for the farmer. So that's where we were focusing on the RlmS resistance in our development and as an efficient alternative for RlmS in the field.
And with RlmS, are we seeing any secondary benefits to other stem-based diseases from things like verticillium, for example?
The RlmS generally gives a good stem health. Whether this has also implications in verticillium resistance, we actually don't know yet. So the resistance response of the plant against verticillium is pretty much different from stem canker. So we have a good understanding of how the plant responds to stem canker, but this is not so the case for verticillium. Verticillium is a different life cycle. So this needs to be investigated maybe, if there is a cross-interaction.
Just going one step further forward, further on in the breeding, we've now got the combination of traits. We have an NL2 variety which contains both RlmS and RlmS. We're combining those genetics. We're also bringing in light leaf spot resistance and also virus resistance. Is that the route in terms of resistance management, if you like, from things like FOMA?
Definitely. For the future, there will be an increased stacking in traits. And there are several reasons, I think, for that. So the first reason probably is the intense cropping of rapeseed Euro-wide in the past 15 to 20 years. So with increased cropping of rapeseed, you also increase populations of affiliated pathogens like stem canker and others, and verticillium. So you need to find measures to combat these pathogens and to keep the plants healthy, and by this guarantee high yield stability for the farmer in the end. Another reason is there was high technical progress on the genetics. So we have now tools available that allows us to select for particular traits at a very early stage of the breeding process or at the plant stage. So we don't need to grow the plants for some traits in the field anymore and wait for infection. We can, if we know which genomic segment is responsible for a resistance trait, we can, at the very early stage of plant life, select individuals from a population and only continue with the ones that contain the trait or the resistance we're interested in. And this technology will even progress in the future and maybe even become less cost intensive. So higher numbers of plant material will probably be processed in this way. And this is a very important part also of our undertakings at NPZ Innovation, so that we are not just, we are running a biotest on the greenhouse level, but we are also investing a lot of knowledge and research, sometimes in the frame of research projects, to acquire genetic information and new technologies that allow us to build up resources for the breeders and to provide genetic tools that makes breeding more efficient and faster.
Just like to maybe summarise a little bit. It's been absolutely fantastic to be able to bring our viewers from the UK out here to Gross-Lusewitz to actually see NPZ Innovation and the work that we're doing here. We've been able to showcase the differential between maybe RlmS and RlmS at the cotyledon stage, and then also have a look at the adult plants. What's really exciting for me is that we've got material now coming through our shareholder MPZ, through LSPB in the UK. We are at the cutting edge of innovation. We showcase the new RlmS foam resistance, and we have that to launch hopefully in 2 very exciting new varieties for next year's recommended list in Murray and Vegas. Vegas actually is the variety here, and we look forward to bringing you into the field to show you those varieties in situ. Stefan, last thing for me would be to say a huge thank you to you and all of the team here at MPZ Innovation for setting up this trial for us so that we could come and witness that today and show our viewers back in the UK. Thank you very much.